So one thing we can do is we can actually find integrals if we don't have an equation. For example, on this graph, we don't have an equation for the graph, but we can still find the integrals, and that's because we know that integrals are the same as areas of a curve. And so since we have very geometric shapes here that we know equations for the areas of, we're going to find the areas and then start to find our different integrals. So I'm going to color some of these in, and we're going to see what kind of shapes we have. So if I use my little crayon, if I color this part in, we see that we have a triangle, right? If we color this part in, let me use a different color, we also see that we have a triangle. If we color this part in, I have a semicircle, right? So half of a circle. And this last section, I see that I have a trapezoid. But since I want to use simpler shapes, I'm going to break it down into a triangle in this part and a rectangle in this part, and then another triangle on the other side. So let's color this part in right here. So we're really dealing with just three shapes, and just as a refresher, we're going to take a look at the areas of these. So the area of a triangle is 1/2 the base times the height, right? The area of a semicircle, well, the area of a circle is pi r squared, but since this is a semicircle, I know I divide it by 2. Sorry, this is a circle right here. And then we know that the area of a rectangle is the length times the width. So we're going to use these three equations to find these areas. And then we're going to take a look at the integrals. So in here, we see I have a triangle, so I know I'm going to use 1/2 the base times the height. Well, my base is 1, 2, 3, so I know this is 1/2. My base is 3. And my height, I'm going to keep track of the signs, is at -2. And if I were to cancel this, I notice my area is going to be -3. So this triangle has an area of -3, and we know it's negative because it's below the x-axis. Same thing, I should have color-coded these. So in here, the red triangle, I'm going to have 1/2. My base is 1, 2, 3, 4. My height is 1, 2, 3. And they are all positive, so I get these to cancel, and I get 6. So I know this right here has an area of 6. I'm going to take a look at my semicircle. My radius is the center of the circle to the edge, so we know the area of the circle is pi. R squared is 2 squared, so that's 4. Semicircle means I divide by 2, so that means this right here is 2 pi. And let's just move, oops, oh no. Let me go back, right about here. And then I'm going to actually erase these just so I have some more room. But let's do this triangle right here. I get 1/2. My base is 1, 2, 3. And my height is -4. So if I cancel those, I get -6. In purple, I see I have a rectangle, which is the length times the width. It's 2 wide times the length is -4, so I know this is -8. And once again, we know these are negative because they're below the axes. And then our last step is another triangle, so I have 1/2. The base is 2, and the height is -4. Sorry, it's squeezing in there. These cancel, and I get a -4. So these are the areas that I found using geometry. What we're going to do is we are going to solve this. So I'm going to split my page, and hopefully you guys have a better copy of that since it's right in front of you. And we are going to do the first part of this. So the first part says, what is the area? This problem right here says, what's the area from -2 to 2? Well, when I go to my picture, I notice that -2 to 2 is that semicircle. And I've already found the area to be 2 pi. Okay. The next problem says, what's the area from 0 to 5? Well, I notice 0 to 5 is half of the semicircle up until this blue triangle right here. Well, we know that the semicircle is 2 pi, but I only need half of it since I go from here to here. So half of 2 pi is pi. Oh, and then, let me undo that plus sign. So I know half of this is pi. And I have to add on this blue triangle, which is a -6. So we know our integral from 0 to 5 is pi minus 6. The next one says I need to go from -9 to -4. So -9 is that black triangle, and -4 is half of the red triangle. So what I do is I have that -3 from the black triangle. Then I need half of the red triangle, so 6 divided by plus 6 divided by half of it gives me -3 plus 3, which gives me an area of 0. Good. The bottom one says I need to go from 9 to 0. So 9 is up here, 0 is down here. So what I need to do is I'm going to add all of this, but because I'm going from 9 to 0, I know I have to make it negative. So I'm going to do a negative sign, and I'm going to add everything that was there. From 0 to 2, I know it's half of the semicircle, which is pi, plus everything after that, so -6. Let me extend this. -8, -4. And if I do my math, I get -6, -8 is -14, minus 4 is 18, so I get -pi minus 18. And if I change the signs, I get -pi plus 18. Good. Any questions on that right there? Alright, so let's do the other half of this. So what I'm going to do is I'm going to copy this, but I'm going to add it right here. And just for us to be able to see the graph again, let me shift this way. Okay. So now I want to go from -6 to 7. If I look at -6 to 7, that goes from our red triangle to our semicircle to our blue triangle to our rectangle. So I'm going to add all of those up, and I get 6 plus 2 minus 6 minus 8. Oh, sorry, 2 pi. I forgot the pi. We notice this 6 cancels this, and we should get 2 pi. Oh, I'm sorry. Well, okay, that's true. So we get 2 pi minus 8. But I forgot to see that there's a constant of 4 there. So I need to multiply this whole thing by 4, which will then give me, and I'm going to move it up here. Sorry for the space. I get 8 pi minus 32. So don't forget to read the entire equation. Alright, the next one says I go from +9 to -9. So what I see is that actually spans the entire thing. However, my units are, my limits are flipped, so I have to make this negative. So I have negative parentheses, and I'm going to add everything up. So I get -3 plus 6 plus 2 pi minus 6 minus 8 minus 4, close the parentheses. Once again, this cancels out. Negative 3 minus 8 is negative 11, minus 4 is negative 15. So I get negative 15 plus 2 pi. But I need to make it negative, negate everything because my units are flipped. So I actually get 15 minus 2 pi. And the last one says I need to go from negative 2 to 5 g of x plus x dx. So I'm going to extend this page so we have more room. Oh, of course it didn't extend. Okay, let's do this. On this page, I'm going to move everything up so we have more room. Alright, so what we see is I'm first going to break this up and I get integral of negative 2 to 5 g of x dx plus the integral of negative 2 5 x dx. So what we're going to do is we're going to go from negative 2 to 5, and I see negative 2 starts at the semicircle, 5 ends at this triangle, so I get 2 pi minus 6, but now I have to actually calculate this, so I get plus x squared over 2, and I must plug in 5 and negative 2. So if I continue this, I get 2 pi minus 6 plus 5 squared is 25 over 2 minus negative 2 squared is 4 over 2. And what we get is 2 pi minus 6 plus 21 over 2. And if I want to simplify this, I multiply this by 2, and our answer will become 2 pi plus 9 halves. So what we really did was we didn't really do much calculus. We started doing the calculus when we started interpreting different properties. So what I'd like you guys to do is go ahead and take a look at your powder blue packet. And I'd like you guys to try on page 2, so let's do powder blue. Page 2. And I want to say this is number 21 to 25. So try those out, and on Monday we're going to take a look at the steps to do this. All right, thank you and have a good weekend.